was no flying saucer.
Hello guys. This time I'm going to be has a faster charge and higher density currents handling, and I have set it over there at where I had on the previous video. I have two of these because I want to run another video with dual caps on each gate of the motor, and we have the same small Radio Shack motor, Old North, and the cap is set at that parallel to that meter there, which is going to be showing the output, and we're going to notice the effect in much faster manifestation here. It's due to the Supercap backing up, and these batteries are not fully charged, and you'll see how the increase of RPMs self within the system, and you will also notice the amperage increases on the DC. These are the same batteries. I have not charged them. They are still the same way. Let me just set up everything here and turn the meter on and set to DC. Reset it to 0, and okay, there is gonna be a point that it's gonna start slow, and then it's gonna start climbing up, and you're gonna notice that on the RPMs and also on that meter when it starts increasing. Now you notice the cap is I showed it out and it's empty completely. 0.002 volts. So let's start the system. We got the starting voltage is at 2.572, and it's at 5,400 RPMs, and you see the voltage went down 13.53, 52, and all of a sudden there's gonna be a point. Now it's at 5,700, 5,800, and it's gonna start climbing up. And notice the amperage is at 4.8890 average, so it's a higher amperage. The motor is right now at 6,300, and we only have at the cab 239 milliamps. Now it's like 67, 6,800. And 1.4 volts. Now it's 7,000. And the amperage remains around 4.54, 4.5 amps DC. Now the cap is at 380 milliamps, and we are at 7,700, 78. So it shows a very actually what it does, the Supercap, what it does, it enhances the features of that we have here. We are 8,300, 78, 8,300. It fluctuates. Now it started coming down. It's 87, I'm sorry, bad setting here. 8,700 steady. It's gonna jump to 1.5. Now it's at 0.5 volts, and it's at 8,700. Amperage remains about 4.2 any. And this is obvious. Now I just don't have the time, the video, but if we disconnect this, we're gonna notice that the battery is gonna increase above the level we started. And actually I have run a previous test where the battery was at 2.566, and when we started it was at 2.572, and it's at 8,700. Motor, it's at room temperature. 95 degrees. Batteries are at 100 degrees, 106, which is pretty warm. Now it's gonna go to 1.6, and it's like 6,300. I'm sorry, it's at 10,900. Bad setting here. It just moved. 10,900 RPMs and 1.6 volts and 3.90 amps. We are at 0.7 at the chargers. We're 11,000 now. So absolutely happy with this test. We are seeing an increase, a gain, and motor is not but warm. And about previous comments that we had on the site, this motor doesn't have any sparks, so I want to get a close look here, and there are no sparks in here, and it's at 11.4 RPMs, 11,000. and I believe it's a good, excellent result here we have. We are 11,577, 11,6, and it keeps climbing. We can have a close-up at that meter, at the tachometer, and it keeps increasing. It doesn't stop. It's gonna get to a point like when the batteries are fully charged, which is around 12,000. And the voltage keeps climbing up. Now we are at 3.68 amps. We're at 12,000 already. And actually the cap is actually, I mean, don't retaining that much, but the same charge that we saw in previous video. We just see the enhanced because of the density of the currents in the motor are higher. Now it's at 12,470, 12,480 by itself. It's just a complete self-acceleration and regeneration of power here. 12,540, and not much time because I want to run another experiment, but I'm gonna disconnect it, and we see the motor keeps running. All right, so I don't have much time left on the battery of the cam, so I'm just going to reset here. Already on DC amps. Turn on this meter, and you see that we got an empty cap there. And I'm gonna run it again. We are at 2.567. have lost what 0.0065 millivolts on that run, which is nothing. We got more current like that on the air. But anyways, let me start it up. And the cap is charging. We are at 1.375. We see the increase again. We are at 4.5 amps, and this I find it amazing because it's the same setup, except that we have the Supercap on the other side of the motor. We are at 7,500 already, and we are climbing voltage. You can see the humming of the motor is steady. Now we're 8,500, 1.44. And 4.17 amps. $9,400. $9,700. 98. $10,000. 10,424. And there eventually will be a moment that if we use dual banks, input output, we are gonna be able to disconnect from batteries. There's no reason why we cannot. As soon as we have a reservoir enough voltage capacity, we can keep running without varying the speed or the torque. And the point will be to find the perfect curve where we can do this exactly at the time the batteries, the capacitor reaches the right voltage and the right amperage, so we can bridge this effect. And of course we're gonna have a slow bump, but the ideal it'll be that it does this effect without batteries, just on Supercaps, and that's my next testing. We are at 11,170 RPMs and 1.6 volts, and keep increasing. Supercap is almost at 0.8 volts. And we hear the motor going up. temperature again, it's 98 degrees, 95, I'm sorry, 96. I believe we're going to enhance even more this effect when we get bigger motors. 11.6 thousand, 11,600 RPM. We have gained a considerable amount of RPMs in a very short timing period, and voltage keeps climbing up. We're almost at 0.8 volts, 3.5 amps. We're gonna hit 11,800, and you guys tell me where we're getting this energy from, because we started with an empty cap. Batteries are rechargeable, but they're only limited to a certain amount of voltage, and they were supplying the amount of voltage was revealing in the amount of RPMs that the motor was doing when it started. Now it's at 12,000 jumping. I find this amazing. It's an excellent effect. I believe we are into something here. Really nice. I'm pretty big. I got no more time, guys, so I have to say goodbye on the battery, on the cam battery. Okay.